So just a group summary. This is really just to kind of wrap up all what we talked about today. So a lot of the slides you will have seen before because I just stole them from everyone else's talk. But I think it's important because there's a lot of things in here. So we talked a lot about results all day. Mark's been going a little bit into the interpretation, so he's given a lot of thought into the structural corridors, but also how that ties in with the other data sets. So again, I just want to highlight really the people that were involved, and there were a lot of them. This was a really complex, long-lived, challenging project for us, probably one of the biggest we've ever done. There's even a second page of people, so it's been a lot. And as you can see from the results of the things that we talked about today, we literally threw the GSSA kitchen sink at the problem and just see what came out of it and what stuck. So there's a lot of new gravity observations. There's a really big fold increase in the MT coverage as well. We really try to kind of build almost redundancy when it came to sampling as much as possible in terms of geochemical, geochronological analyses. And then there's been a lot of work going on at the near surface in terms of lineaments, etc. So really just trying to go from the deep to the shallow. So there's a lot of videos you can watch. There's already been quite a few report books published, papers in review, and there will be more coming out. We probably want to put some sort of abstract volume together as well over the next few months, hopefully. So what I would like to do is maybe put this into an overview. So if you believe people like Ken McQuaig and John Hronsky, this is the ingredients you need to build a mineral system. And what I'm going to try and do is perhaps cast some of the things that we talked about into it. There's really the three main things: fertility, the architecture has to be right, and some sort of transient geodynamic triggers that leads to the orogenesis, and then hopefully it survives the time as well. So it's been a long time since we've seen any of that. So I want to start by the architecture and just kind of what we learned from the survey. So I guess everyone's talking about fundamental basement structures, and I think what you've found out from a few of the talks and also what Mark talked about is that the Kurobi shear zone is a structure that we believe is very fundamental here. There's been over time a lot of movement happening along that, and also it's kind of really guided from where you grow your crust outwards from there. So that really came across in Dylan's talk and also Mark's talk and Claire's work of that this is sort of almost a fundamental structure where everything builds up on. And you can see that again in some of the geophysical observables. So everything sort of west from there has a sort of relatively coherent story, which we think plays a role, especially for the nickel-copper prospectivity. Again, having a gravity high, which kind of tells you have sort of a lot of mafics there. Really depleted upper crust, which probably was sitting lower in the crust itself from the MT. So that kind of tells a fairly coherent story. The next point that leads on from the primary architecture is the favorable geodynamics. So it's the idea that you have a source at all times, but you need to kind of break through some sort of threshold burst, some sort of dynamic trigger that really enriches your ore. Otherwise, you don't get the concentrations. So what do we learn from that? This is really building on some of the work that Dylan has done. That throughout the time around 2490, 2460, we have these multiple generations of mafic magmatism that really is facilitated by the bigger structure growing out from there. So we have these sort of geodynamic triggers at a few times that kind of seem to be in the right geodynamic triggers for orogenesis. Just want to rehighlight what you just heard from Mark. So again, the Kurobi shear zone, multiple reactivation over the course of time, obviously at 2480, which is really important for the nickel story. But we also see during the Kimben is around 1700, so that plays a bit of a role for Gulf bore, which is something that Alex alluded to, that there's a second age that we're getting at Gulf bore. Again, that's to do with reactivation along the Kurobi shear zone and also compression at 1690. And then the next event that Mark highlighted at 1610. So again, the story here is that the Kurobi has seen a lot of repeated triggers over time. In terms of fertility, and I really like what Claire mentioned the other day, that it's the sort of magmatic proclivity or productivity of the magma for really that kind of says what fertility really is. So what do we know from here? That over time again we had multiple events that kind of really prime your lithosphere. in terms of making it more fertile. So, an old subduction zone, and then a slab break off, which, just produce a lot of morbs. But then over time, you do see a progression from looking out from the Devil's Playgrounds, Lake Harris Komatiites, again, ultramafic infusions, and until up you get, again, signatures that are quite looking at that you have magmas coming through and interacting with the crust and really picking up a lot of material. So it's quite an enriched lithospheric mantle signature that we have there. So that kind of really speaks to fertility, that there's enough material around that can be absorbed and then brought to the surface. And again, we do see this over time. I really quite like this plot. It kind of shows that you have multiple rejuvenation events throughout time. So on the right-hand side there, and also highlighting where you have a lot of nickel mineralization. But again, these are events where you might have subduction zones or some plume interactions that are kind of really melting and remobilizing, metasomatizing the lithosphere and then bringing it up to the surface. And again, there's multiple events here that will trigger even around 1700 and later, to really increase the fertility and then give you a chance to form some ore deposits. So what are the implications for nickel and gold? Really, that's a great summary slide. So I think Mark's kind of work around identifying these corridors is really important. So it's something we haven't really looked at before. So this is kind of to interpret really a work of looking at the different structures here, but then also where they are relative to the main Kurobi shear zone, and obviously the work that we have around the ages and the geochemical footprints really helps with constraining where those corridors are. For gold, I think the story is a bit more complex. It seems that a lot of the smaller scale structures are really quite important, and we just don't have the resolution in our data set to really constrain those well. So this is probably work that you still have to do with a different resolution and looking much finer. And it's very likely that, so for example, one model for orogenic gold would suggest that you might even see lower crustal footprints even in the MT or resistivity images. We don't see any of that. So it's very likely that those footprints have disappeared. And then Challenger Golf Ball have a shared history, so that's something that Alex has talked about. So there are some really interesting work, but I think from our point of view, there's still a lot more work to be done rather than kind of what we've really been shedding some light on with the more regional data that we collected. So then there's obviously preservation, and I just want to finish up with that. You kind of want these systems to survive, obviously, and I have talked about earlier that we are pretty certain that a lot of exhumation must have happened just because we are seeing granulite facies metamorphism at the surface. And again, this match between the MT resistive zone and the gravity high here, I think plays a major role because it does kind of tell you that what we're seeing now in the upper crust has probably happened more in the lower crust, and we have actually refertilized the lower crust again. That's what we see in MT at the deeper depths. I also want to really finish up by mentioning some of the work that Carmen and Bahong has done. So this is more about the linear mapping and just connecting the subsurface to the surface. So this is really quite critical to see where a lot of those deep basement structures are coming up to the surface and where you might actually have a chance to explore and maybe even use geochemical analysis to look for those. And then also paleochannels, because it gives you a fairly good marker of where you might transport some of those metals along and where they might have disappeared. So having these data sets from the AM, the gravity, and the MT, 3 independent data sets that kind of tell the same story there.